Hello and welcome, dear students, to the course of Supply Chain Management that is MS 491 and is being offered for the summer 2020 semester. The course is a part of your online classes that are going since March 2020. And I'm your course instructor, Hassaan Tariq, working here at the Department of Management Sciences at GIKI Institute. Nonetheless, this is a service course basically designed for the engineers. So for today, we had been discussing some key concepts about supply chain in the previous lectures. So for today, we'll be going through an important concept that is inventory management. So exactly at the conclusion of this topic, I expect the students to have an idea exactly what is inventory management and the types of inventory. Well, this is a repetition. Well, the next part is what is inventory planning and ordering systems, and finally we'll go through the inventory control systems. So at the conclusion of this topic, the students should be able to go through all these concepts and relate them from theoretical perspective to more of an industrial or practical perspective. So we begin with our definition of exactly what's inventory or what's inventory management, right? So inventory is a resource of any kind having an economic value, all right? So something obviously that has a physical existence and some has an economic value as well, like someone is really willing to exactly buy the thing. So inventory consists of raw materials, work in progress, finished goods, stores, and scraps. Thus, the inventory management is all about planning and devising procedures to maintain an optimal level of these sources. So, it also basically gives us an idea to exactly the importance of inventory management is basically to work through with an optimum quantity of materials. So exactly, quickly, let's move on that what's the purpose of inventory management? First purpose is that inventory always acts as a buffer, right? So in case of demand fluctuation, you might have increased demand in the market and you have stored inventory in your warehousing or your stores. That obviously acts as a buffer and really helps you out to basically overcome that sort of demand fluctuation. And nonetheless, inventory also helps in having a balance of demand and supply, and we'll look into further how this really works on. So, well, people, let's move on with the first part that is your types of inventory, right? So we have a lot much types of inventory. The first one being raw material. So exactly we define raw material is something that has been purchased but not processed, right? So well, I need to make a body frame. So aluminium is my raw material that has been purchased by the organization from the suppliers, but nonetheless, either we make that into a car frame. We cannot say that it's in the next shape. So by that time, it's raw material. In raw material, there is another category that we call as semi-finished assemblies or modular assemblies as well. So exactly the semi-finished assembly or modular assembly is more relevant to your agile supply chains and well lean supply chains as well, lean manufacturing as well. So semi-finished goods is something, well, you can say that obviously in the automotive industry, most of the things are being assembled on the assembly line, right? So all the components like engine, the car seats, the car battery, the handle, the tires, everything is coming in modular components. The components had already been processed by the suppliers, right? So the engine had piston, it had the belts, it had the ignition, the all the electronics that control your timing and stuff like that. So all that has been basically already manufactured by the supplier, and currently the basically the assembler of the car is using that in a modular design, right? So that is your semi-finished assembly that has not be exactly finished, but is ready to be assembled or fitted into some sort of a product. The next one is work in progress. So obviously we know that on assembly lines, or if we have batch processing as well, and some products do really take a lot much time for processing or manufacturing, then we say that particular thing that is either being assembled or still the work is being done. Well, supposedly I can say like pumps as well. So I can say that the pumps Initially, they start from the molding and the casting operations, then they go for the machining operations, then they go for the paint job, then inspection and stuff like that. So I might say that, well, I have like 10 pumps still in my paint shop that are have been already molded, casted, and machined, but still need to be painted. So I'll count them as my work in progress inventory. Obviously, that has not been really finished, but still the work is in progress. So that's the reason we call that as work. The other part is maintenance and repairs inventory. That is basically just to keep the work moving, right? So maintenance, repair, operations inventory is similar to what it looks like at this point. So the maintenance department has all the available inventory that really helps you to keep the things going. So it can be all the way from the tools, it can be your other equipment that might be required on the assembly line, like LCD screens, like conveyor belts, like rolling tires. So all these things are more of a maintenance and repair. And obviously, if we don't really have these inventories in stock, then obviously our production or the manufacturing can be halted. The next one is finished goods, something that has been finished and is awaiting shipment. So, example of finished goods, a lot much stock of the cars is waiting for shipment. So, exactly the product has been made but not yet delivered to the customer. And finally, the other type of inventory, goods in transit, because obviously we know that the companies work globally across the world, and it really takes somewhere around, well, 20 days roughly to have, or 14 days to get a sea shipment from China to all the way to Pakistan. So by that time, by the time they are in transit, or by the time they are basically over the sea shipment or whatever the mode of transportation is, we call them as goods in transit. So exactly the functions of inventory. Well, first thing is to manage fluctuations in your demand, right? As I told you previously, that there might be a hike in your demand. People or the consumer might be really buying that stuff a lot much. So just we had a situation in the start of this COVID-19. A lot much hassle was going on for hand sanitizers, for gloves, for masks, tissue rolls. So all these stuff, what happened exactly? There was a high demand in the market, and there was a lack of supply that had to come all the way. So all those who had stocks of inventory with them were really able to work in this situation because they were able to basically use their inventory. And in countries like Pakistan, the bad thing is that these things are, well, stocked for selling them in the black market. That means that selling them at much higher prices. So exactly, this is the key principle that inventory is used basically as a buffer. It is also used to streamline the production functions. Obviously, if you have the inventory in stock, your production really can't be stopped, right? It keeps on moving. The flow of inventory is there, the flow of goods is there, and finally, you can produce your finished goods as well on time. Take advantage of the quantity discount. Well, this is basically if you buy more in bulk, because you know that if you buy something in one, you have a different price to pay. But if you buy like 10 units of that particular item, you are given discount with that. Similar to the Pepsi and Coke that is being stocked by the big retailers, that if you buy one bottle of 1.5 liter, you pay 100 rupees for that. If you buy four bottles, obviously mathematically it should be 400, but you pay 350 for that. So basically this is having more of quantity discounts because you're really helping the manufacturer to get his stock really get off. To hedge against inflation, so obviously in countries like Pakistan where the inflation is rising, and you really need to counter that basically thing. So in case an organization says, well, we have money right now to buy, supposedly we can say that, well, elevators or stuff like that, and they say that, all right, well, let's just buy some inventory or some elevators right now, and we may later on basically sell them in the market. So basically, the company is foreseeing that in the future the prices might be increased, might be due to currency fluctuation, might be due to inflation, whatever the reasons are. They basically stock those items and sell them later in the market. So basically, this is more of cost saving stuff that exactly you try to avoid spending a lot much cost on your inventory. Obviously, to meet the customer demand and to manage stock out. Stock out is something that if you don't have any thing on the shelf, obviously that means you have run out of stocks. and you're not able to work along with your customers' demands. So, people, before we move into the next bit, let's really discuss that exactly what are the types of demand. We have two key types of demand. The first one is independent, that is more of an unpredictable nature, and the other one is dependent, that is more of predictable in nature. So we can say that, well, selling a car is independent demand because I don't know, really don't know that at what time the customer will be coming in to buy a car, right? But the dependent demand is that supposedly a customer has ordered the car. You know that every car requires four pieces of tires, one handle, uh, five car seats, right? One engine. So these are what? These are dependent demand. They are really dependent on the amount or the car that it has been bought up. So these are fixed roughly, and you can very well predict them that for every one car you need four pieces of tire. So this is an example of dependent demand, right? So before I move further into details, let's have a look exactly how Amazon receives your inventory. So have a look through the video and let me make sure that everything is being recorded. So yes, there you go.
Amazon fulfillment centers are complex operations in vast spaces. Our prep, labeling, and packing requirements are designed for our fulfillment center associates to handle your units as efficiently as possible. This allows us to process millions of orders every day and helps Amazon provide the best experience for our customers. Before you ship your products to Amazon fulfillment centers, it is important to make sure they are packaged properly and are e-commerce ready so they can be quickly received and available for sale. Each unit that arrives at our fulfillment center that does not meet our requirements delays the receipt of your inventory and increases the risk that a unit could be lost, damaged, or incorrectly received. When your shipment arrives, an Amazon associate scans the shipping label to ensure each has a shipment ID that exists in the system and that the shipment is at the proper fulfillment center. Multiple boxes must not be taped or banded together. To avoid any confusion, your shipping boxes should not have any other scannable barcodes except the shipping label. Boxes that do not match our size requirements require special handling, which delays the receiving process. The next step in the inbound process is opening the shipping box. If the shipping label is placed over the seam of the box, it can be easily damaged in transit, become unreadable for carrier and Amazon systems, or be destroyed as the Amazon associate opens the box. Place shipping labels on flat surfaces to ensure that the label remains scannable throughout the inbound process. An unscannable shipment label can cause delays in receiving your units. The best packing materials, or dunnage, to use are foam, air pillows, or full sheets of paper. Packing peanuts and shredded paper slow down the receiving process. For this reason, we do not allow loose packaging materials to be used in inbound shipments. Amazon also verifies that individual units in the shipping boxes have scannable barcodes. Each unit should only have one scannable barcode. If a unit does not have a scannable barcode or has multiple scannable barcodes, it will be sidelined for proper identification by an Amazon problem solver. Case-packed units must only have barcodes on the individual units and not on the outer carton. Barcodes on the outer carton could lead to multiple items being received as one unit. The associate evaluates if the units need additional prep to ensure that they won't become damaged during storage and shipment to the customer. If prep is required but was not performed prior to being received at the fulfillment center, the units are sidelined for special handling. Also, items should not have any loose packaging. Products that require additional prep upon arrival at the fulfillment center are delayed from being placed into inventory. Depending on the number of units requiring prep, this delay could be 2 hours or 2 days. Units that don't require additional prep are sent to be received. During the receiving process, the associate performs a 6-sided check of each unit to ensure the unit is not damaged. Please ensure each unit is packaged properly to avoid being damaged in transit. Also, the associate performs a title verification. If the title and product do not match, the unit is sent to an Amazon problem solver. The unit is now received. The unit is routed to be stowed. If there were problems in any part of the check-in or receive process, units will be directed to the Problem Solve area. Units that must be sidelined and evaluated by a problem solver take longer to receive. Problem solving is a very detailed process, so time is taken to ensure each problem is resolved properly. Once the problem has been solved, the units are received and placed in a tote. Units that have been successfully received, even those that required Amazon to perform special prep or problem solving, now take a trip on the conveyor. These units are sent to be stored in inventory. Every unit is scanned into a location so that Amazon knows its exact location. Now, when a customer orders your product, it can be quickly picked, packed, and shipped to them without delay.
All right. So exactly this video to really tell you the importance of inventory management. You had seen that throughout this fulfillment center, there are a lot many units that are basically being moved here and there, and obviously it requires a lot much accuracy as well. Similarly, you really need to make sure that the inventory is of the right quantity and the right product is delivered to the customer within the right form. Because if obviously there are damages to your inventory, it really brings up costs. So nonetheless, just to give you an importance of exactly how important is inventory management, we had been going through this. So let's exactly discuss the points that why do we need to hold finished good inventory, right? Few stockists and a few companies really hold the finished good inventory. So we really need to make sure that why do we need to hold that particular thing. So let's discuss the first thing is that market and supply chain design, right? So your market or your customer segments might be in such a form that you really need to have to store and stock your stuff. Similarly, the next part can be your production strategy. That is either make to order or make to stock. So if you go for a make to stock strategy, obviously you really need to stock those items in your inventory and sell them later into the market. So this is more like push production, and we'll be discussing that within this lecture as well. The other reason can be market penetration. You have sales campaigns that have to meet the demands within a less amount of time. Then you have the market size and the location. Obviously, you have different markets, you have various locations, a few are accessible, a few are not accessible. So you really need to make sure that exactly which of your products are going to which area. So you might really be looking for stocking those products. Obviously, you have transportation and physical barriers for the village and the hilly areas. Then you have taxes as well. So supposedly we have a few tax-free zones. So companies might really be looking into stocking inventory. We have production lead times, and we have stuff like yearly maintenance as well. So that really basically stops your production, and obviously for that time as well, you really need to give your deliveries to the customer. So you really need to stock your inventories. The next part is speculative gains. Well, speculative gain is mostly used in cigarette industry within Pakistan. Exactly what happens that well, we know that the government imposes health tax every year on the cigarettes, and that really gives a good benefit to the suppliers and the distributors as well. So they basically stock cigarettes before the budget announcement for every year and really try to make profits out of it. Uh, Good, bad, ethical, non-ethical. Well, we are not discussing that, so simply discussing the practical aspects of it. And finally, obviously, to meet your customer satisfaction, because if thing is not there on the shelf, but that means that you have lost your customer. All right, people. So with every sort of inventory, we have certain costs. So the first cost that we will be discussing is the ordering cost, or we also call that as setup cost, right? So obviously, if you have to order inventory, you really need to call your supplier and ask him for the inventory, right? So this is a traditional way. But now what really happens that There are lot models and other stuff like that. So what really happens that the inventory, basically the demand really goes back to the supplier from the manufacturing, and through an automated system that can be through ERP softwares and other stuff. So the supplier is available that what product needs to be made at their end and how it really needs to be made. So supplier schedules his manufacturing as per the schedules, and similarly they have a schedule to deliver it to you as well. That is delivery schedules as well. And similarly, the manufacturing has their own manufacturing schedules, so they really look into supplier schedules and their own schedules. Well, so exactly what is happening that if you are ordering your inventory, it really needs some costs, right? There are some costs associated with that. So that can be obviously your phone cost, your emailing to the supplier, your HR people, your infrastructure, that can be your technology. Obviously, you need financing, then you have banks and letters of credibility. Because if you are basically ordering stuff on credit-based systems, you really need to have letter of credibility to make sure that you have that much amount of money in your accounts. So all these are your ordering costs that can be associated while ordering inventory. Apart from that, the other costs can be basically your transportation, loading and unloading, tracking cost, your communications, later early delivery, port charges, custom duties, third-party verification, insurance cost, documentation cost, shipping agents cost, cost for the chillers as well, emergency cost. Obviously, if the stocks really turn out, you really need to bring up things at a much higher pace. So all these costs are basically associated with ordering your inventory, right? Let's move on to the next type of cost, that is holding cost, or we also call that as carrying cost. So holding cost is the cost to carry an item in the inventory for a length of time. So in the holding cost, we have the facility cost that includes the warehouse, you have the product segmentation, your distribution center, and your infrastructure. Then you have the HR cost. Obviously, you need labor to move the inventory within the warehouse as well, right? Then you have the financial cost that can be cost of investing somewhere else, lost opportunity cost, management costs, people sitting in the HR, white collar jobs. You have replenishment costs. Then you have shortage cost as well. Obviously, if something really goes missing through your warehouse, obviously you have to bear the shortage cost as well, right? Because mostly in the warehouses, what happens that you have a lot much people working, and most of them are not permanent employees. So you really have to work and rely on people who are working on daily wages. So exactly you can't rely on them. So most of the time, you can have some sort of losses in your inventories. Then you have obsolescence cost. Obsolescence cost is more towards technology. If obviously, supposedly, well, I say that someone in Pakistan is having a mobile shop and well stocks mobile phones for roughly 1 year. So exactly what happens that the mobile phone models are changing like after every 3 months, right? So what really happens that if you really keep a stock for a year and you know that the things are really changing after every 3 months, then what happens that you have to bear the obsolescence cost. The thing might not be able to be sold off in the market or might not be able to sell off at the right price. So in that case, you really bear with the obsolescence cost. So that is also one of the holding or the carrying cost. Then you have the damage cost. Obviously, if the inventory damages, you have to bear the cost as well. You have your inventory shrinkage cost as well, that is more towards theft and stuff like that. And you may also have to face product recall cost as well. Obviously, if your product has failed and you have given a warranty with that, so obviously you need to recall that thing back as well. So these are some of the costs associated with your inventories. Let's come on to some of the concepts that are really used in the industries for inventory management. So the first one is basically for your computer industry that uses a vendor managed inventory system. The other one is the manufacturing organization who mostly rely on just-in-time inventory, and in the apparel industry, the same just-in-time inventory is also known as ECR, or efficient consumer response. For the just-in-time bit, let me tell you, simple layman definition is right thing at the right time, right? So basically, just-in-time is an inventory management system used to manage the stock that is kept in storage systems. It involves receiving goods from suppliers as and when they are required, rather than carrying a large inventory at once. So exactly, let's have a look into how just-in-time inventory works, and before that, let me make sure that things are really being recorded. So that's perfectly fine. All right. Sorry about that. Just issues. Right. There you go with your just-in-time inventory.
All our factories have implemented the well-respected Toyota Production System TPS, also known as the Lean Manufacturing System. This is based on the pull system, which means we only produce what is ordered.
Your order will be placed in the exact sequence of that allocated day to ensure a levelized workflow in the factory. We call it a GIKI, and our suppliers are doing the same in order to make sure that the components will be delivered just in time.
Donc ici, nous arrivons au service planning. Nous sommes en charge de planifier les commandes de manière à respecter l'Injunka. Chez nous, c'est Christophe qui s'occupe de ça. Derrière, l'objectif, c'est de livrer les machines à l'heure aux clients. Et aujourd'hui, on est à 98% de machines livrées à la date promise.
Here at the assembly line, you may see as the parts are directly driven and delivered to the operator, strictly following the assembly sequence put out from our production planning. Just-in-time principle is very important because we are delivering the right parts at the right moment, when they are needed and where they are needed.
Il mio lavoro è semplice perché è tutto standardizzato e mi permette di imparare molte postazioni.
In order to continuously improve production, quality and safety in our supply chain, we hold regular meetings in our factories. For example, at 10:30 is established the ASA meeting where group leader can update all the department about the major issues they find on the assembly line. According to this meeting, every day we can have a step up on quality improvement.
To efficiently inspect quality and improve it, operators are performing quality check before sending their work to the next step. When the truck is completely assembled, we perform final inspection.
Il 100% dei nostri carrelli elevatori viene collaudato ed ispezionato per garantire al cliente un elevato livello di qualità.
In case you have an issue on your product, we have a robust warranty claim process. Every single faulty part is coming back to the factory to be analyzed. This is deployed across our European factories.
In quest'area controlliamo i pezzi che riceviamo dal campo. Nel caso specifico stiamo controllando dei componenti ricevuti dalla Spagna. Il test consiste nel confermare oppure no il difetto che ci è stato segnalato. Se il difetto verrà confermato, il pezzo verrà spedito al nostro fornitore, il quale provvederà a fornirci tutte le contromisure necessarie per evitare che la cosa si ripeta in futuro.
Once the issue has been resolved, we standardize the solution inside of our production process. As a result, for the last 10 years, we could reduce the number of warranty claims by 70%. Toyota.
So exactly that was about how basically just-in-time inventory really works. All right. Well, this thing should really allow me to get on to the next slide and know exactly what is really happening. So all right, so that was exactly what just-in-time inventory management is. The next one is your vendor managed inventory, right? Well, what happens in a vendor managed inventory is that the supplier, not the customer, is responsible for managing and replenishing your inventory. Usually based on retailer sales information, goods or materials are only sent when the stocks runs low, and the lead time is factored in, right? Let's really have a look at how vendor managed inventory systems ready to work.
Hi, I'm Kayla and I'm with ARC Safety, and today I'm going to be walking you through the steps of how to use our vendor managed inventory program. So let's take a look inside, and the first step is going to be using our fob for entry. Just hold it up to the lock and open the door.
Please scan next barcode or select finish.
You may notice that there are voice prompts that are going to be walking you through the entire process. And I should note that if any of your employees have Spanish as their first language, that the voice prompts can be programmed with their fob to instruct them along the way in Spanish. So the first thing that we're going to do is scan a product. We just pick up the barcode scanner. We'll scan some of these earplugs.
How many
Take
pairs?
one pair. So I just come back up to the screen, hit 1, and hit complete.
Please scan next barcode or select finish.
That item is then added to the completed transactions list, and we have the option of either hitting finish to end the transaction completely, or if you want to continue checking items out, you just keep going. So that's what we'll do for the explanation process. We will take, let's see, how about we take a tape measure?
How many individual items?
Take that out and say that I'm only taking one.
Or select
Hit
finish.
the quantity of 1 and hit the complete button.
Please scan next barcode or select finish.
This is all that I need for today, so I'm going to redock the barcode scanner, hit the finish button.
Thank you.
And walk out with my products. Okay, so now I'm going to take some time to show you some other types of transactions that you may experience while you're in the cabinet, different from your traditional, just taking something.
So basically, a part where basically exactly the manufacturer is not really managing the inventory, the vendor, either that can be a supplier or that can be one vendor who is really managing all your inventory. So it can be an automotive company and they have hired some vendor who is really managing all the inventories in terms of engines, car seats, and stuff like that. So it really helps the company to minimize the cost, and obviously the company is not really much competent in terms of inventory management. Then obviously you hire someone for this sort of service, and exactly you try to have reduced cost and much better flow of inventory, and obviously reduced risk as well, because most of the risk is turned towards your vendor. The next bit in inventory management is your inventory ratio. That is one of an important sort of a calculation that is really used in inventory management. So what happens that inventory turnover ratio is basically cost of goods sold over your average inventory, right? So the ratio is a sign that the company is not overspending on inventory and has more liquidatable inventory. High inventory turnover ratio, simple as that, means that you are really able to sell your inventory at a rapid rate, whereas low inventory turnover ratio states that the inventory is not really being sold at a high pace, right? Similarly, we have day sales of inventory, that how much time it really takes for, in terms of days, for the inventory to turn over. That means to be replenished from the shelf. Then we have the formula for this, that is number of days over your inventory turnover ratio. I do have some practice questions for you that you can really go through, and the solutions for the practice questions have been provided within the slides. So all those having the slides with you, can you just go through and make sure that you practice these very well. All right. An important concept in inventory is there are various inventory ordering systems, right? And inventory management systems as well. So let's have a look into a few of them. Perpetual inventory, double bin, 2 bin, 3 bin systems, and just-in-time and VMI have already been discussed, and then we later move on to these inventory planning and control systems. So before I move into the inventory systems, let me tell you that there is something known as Kanban card. You might have heard, if you are from mechanical engineering, So Kanban is a visual method for controlling production as a part of just-in-time and lean manufacturing. As part of the pull system, it controls what is produced in what quantity and when. Its purpose is to ensure that you only produce what the customer is asking for and nothing more. So this is more of an example of Kanban cards. Exactly who was the supplier, what's the part number, what's the item, what's the quantity, and similarly they are used for displaying in your manufacturing environments, right? And we'll really look into how they are basically used. So simple as that, in a convex system where you have continuous work in progress, what is really happening, you have process one, you have process two, and you have the product supermarket or something as Kanban board as well. So what happens if product A is basically scheduled in process two, right? So product A is now the first in sequence in terms of scheduling. So that means that product A will be the process two that might be polishing. So you'll be polishing product A, then product B, then product C, then D, and then I. All right. So exactly what happens that you have already B and C in your product supermarket, or they have already been finished from process one. So they are still in the waiting line or in the queue for process two, right? So what really happens that if product A moves from this queue to your process two, and then you release the card, then your product D basically moves from process one to the product supermarket and obviously gets into its queue. Similarly, at this point, what will happen that product I, if product D moves from this point to this point, then the product I that is somewhere here, that is outside the process one, that will basically a card will be shown and visibility will be given and product I will be moved to process one, right? So this is just to give you an example of a Kanban card. How to make a Kanban board? Exactly, let's have a look into that. This is more of a practical aspect. How
hey guys, today I'd like to show you how to build a Kanban board for your Sharona Kanban team. So to get started, all you need is some loose painter tape, some Sharpies, and a bunch of Post-it notes of various sizes and colors. So you use a Kanban board on your team to visualize the workflow so that the team can track the work that they're actually working on. So the first thing I like to do is to build a horizontal row for the Kanban board first, and then create 4 vertical columns. So let's go ahead and do that. All right, so now you've created your first Kanban board, and now you need to label each of the column states. The first column is your backlog. This is your master backlog for the project. Highest priority items go high, and lower priority items go low. Next column is the to-do column. Then the in-progress column, and then the done column. This is the simplest Kanban board to implement. Shows each of the statuses. Now you want to populate your backlog. You use story tickets. I like to put a certain amount of information on my story tickets. I like the title, an XYZ user story format, definition of done, points. You might put acceptance criteria on them, and you can even use the back of the ticket if you need extra room for information. So let's populate our backlog.
Well, obviously, if you're in a manufacturing environment, you can replace the story 1, 2, 3, 4 by product 1, product 2, or item 1, or order 1 or 2, whatever it depends based on the nature of your industry.
So as you plan as a team, you take items and you put them into the to-do state.
So this is more like sequencing, exactly to do what to do. So this is more of a sequence, the first things first and the last things last.
And every day,
So this is more of a FIFO method, first in, first out.
Together in front of the board, and they take
you may use LIFO as well.
States. So now that we start working on this story, it gets pulled over.
If it gets into the process, you put that into in progress. And what happens, you are basically visually giving a sign that your to-do list and your backlog is empty and you can add on more products or orders.
For example, this orange sticky might indicate a specific person on the team, while this blue sticky might indicate someone else on the team.
So this is basically the project is assigned.
You can use
more of an agile project management.
this is a block store. And there's your flag that tells everyone that story is blocked. And then when the story is unblocked, you simply remove the flag. As stories get worked on, you move them over to the done state. And you can even track emotional state of the team by using smiley face and frowny face avatars. This story was really fun to work on. Well, this story was terrible to work on.
That's more of a
These are the basics of a
retrospective.
Kanban
Exactly,
board.
you go
I
through the
also
feedback,
use them as
exactly how the
information
things have
documents.
been
For as
done.
much information.
So hopefully you understood by this how to really make through a Kanban board. All right, so what we really discussed at the start was exactly what is push and pull systems. So getting on with the push system is something where you basically buy things from the supplier, manufacture them, assemble them, throw them into the market, right? This is push production system that a push is being generated into the market or into the retail store. So exactly what sort of products can be? It can be your daily commodities like wheat, oil, your groceries that have to be bought by the user, right? So exactly that really works more on push production. You don't really much look into optimum levels of inventory. Rather, you are more concerned about putting the things in on the retail store or on the distribution center. Well, it can be on your service area as well, right? If you're a car servicing company or after sales and service as well, right? So basically, your ultimate aim is to make sure that your product is being sold off into the market, right? Because this is mostly things where you have a much amount of alternatives. The users don't really have a high amount of switching cost. They can either buy product A, either by brand B, either by brand C, right? So it does not really matter that which brand they are buying. It only matters that whatever is there on the shelf, just go and buy that, right? So that is more of a push production system, which is mostly been done in countries like Pakistan, which are more like developing economies. Then there is a pull system that is more for your customized products. Quick example, Dell laptops. Everyone has a different need. Everyone needs to have their laptop of their own choice. So exactly in that part, the supply chain really starts from the customer. In push, it really starts from the supplier. And in pull system, it really starts from the customer, or it is more of a new part of a new sort of a supply chain, right? So the customer basically orders his laptop over the internet. The order goes back to the manufacturing company, that is Dell. Dell sends their order to their vendors, and the vendors put up the things. They have a vendor managed inventory system. So what happens that particular vendor really adds up, gathers up all the things, puts that in a tote. Tote is like a box, and the things really travel into your production site. Then the Dell assembles those laptops, right? So someone might be looking for a 15-inch screen, someone might be looking for 1 terabyte hard disk, or someone might be looking for a 500 GB hard disk. Someone might be going for a DDR3 RAM, someone might be really looking for a DDR2 RAM, someone might be going for USB 3, someone USB 2. So everyone has different range of options that can really add it into the product, right? So what really Dell does is more of a production. So whenever the order comes in, Dell starts working on it. It starts its assembly and stuff like that, and really gives you time that at this time this particular product will be delivered. So exactly, just an example. Well, here is your delivery from the supplier. So this can be your company that is really planning the schedule. So you have 1, 2, 3, 4 operation, and finally you have finished goods and you throw the things into the market, right? In the pull system, what is happening exactly? Things are coming all the way from where? Exactly your previous process. So process operation 4 says that, well, this is vacant, right? So in that case, what happens? You start moving with the operation 3 is basically transferred to operation 4. This is more of a Kanban card system example, but obviously, if you look into a supply chain perspective, it is really something that the customer orders. It really goes back to the manufacturing. Manufacturing orders their suppliers, right? And then the process moves forward with the inventory. This is more towards production, exactly how the Kanban cards are basically used to really give a sense of visualization that exactly which part is really vacant and which process can be completed. The other inventory management system that we have is 2-bin and 3-bin system, right? Within a 2-bin system is used in warehouses, mostly used for C-class items or low consumption items. We really look what C-class items is. An item can be stored in 2 locations or bins in a warehouse, and the stock is replenished in the first bin from the second bin once the first bin is consumed. Minimum quantity value is set. Required quantity to be filled in the second bin is placed for order. The availability of the stock in each bin is calculated, and high demand replenishment interval is short. So exactly this is where I'll be explaining you 2 bin system. So there is one main bin, right, and then you have a reserve bin. So I might say that this can be my production line or assembly line or my distribution center as well, right? Well, more of an assembly line, and this is at my supplier's end, right? So this bin is basically with my supplier. This bin is lying with me, and I'm basically assuming myself to be a manufacturer, right? So what really happens that I basically send my requirement to the distribution center or the store, right? And they basically ask the supplier to send up the other bin, right? So if I say that I have 100 units in bin A, and the bin is really being used at one point, and I say that once I have 20 units left with me, that will be my reorder point, right? The point where I really need to reorder that particular amount of quantity that will be communicated through the store or the distribution center or directly as well, right? And in that case, another bin of 100 units will be sent by the supplier to my shop floor or my warehouse, right, or the storage center. And in that case, first bin that has been emptied by that time, that will really go back to the supplier, and the supplier will really start working on the bin A, and bin B will be in use, and bin A will be with the supplier, right? So this is your 2 bin system. I have to tell you through a video, so let's really look into how really this thing works.
Hi, this is Dan Matthews of Lean Keys. Today I'll be explaining the basics of the 2-bin system and some of the keys for effective use. Like any Lean tool, it may not be suitable in all areas of your facility, but there are definite benefits for using a 2-bin system. As I talk about the basics of a 2-bin system, you'll see an animation depicting how simple a process it can be. As the name suggests, inventory is kept in 2 bins. After depleting the inventory in the first bin, all you have to do is turn in an empty bin. The empty bin with its affixed reordering information acts as a Kanban. While the bin is being replenished, the worker uses the material in the second bin. If your calculations are correct, the empty bin will be replaced with a full bin before the second bin runs out of parts. The advantages of a 2-bin system are that it reduces the chance of running out of materials or parts. It makes parts reordering easier to manage. It reduces downtime due to workers having to go and get their own materials and parts. And it makes replenishment simple while making the abnormal condition obvious. Generally, you'll see 2-bin systems used in assembly areas. The 2-bin system is also an excellent tool for managing office supplies and can be used successfully in the healthcare industry. The 2-bin system is a method that helps automate the parts reordering process, removing the need for complex analysis or material handling processes. When used properly, the 2-bin system is an excellent visual management tool for parts replenishment. During a recent 5S Kaizen event at a client's electrical wiring and lighting department, I noticed a man inventorying all of the electrical components on the shelf. I later found out that he was their electrical supply vendor and that he can...
Well, just quickly
conducted an inventory twice a
All right, so just a quick thing, you have 2 bins, right? And basically once the first bin was finished, an order was generated with the supplier, right? And the supplier basically replenished that bin, sent you on your shop floor, and once the other bin was finished, it was replenished back by the other bin that was already with the supplier. So similarly is a 3-bin system with 1 more bin added. So exactly this really basically what really it gives you the advantage of really making sure that your production systems are going with a continuous flow. You don't have any sort of production halt or stoppage. So exactly the same thing happening. You have a shop floor here, you have a warehouse, you have a bin with a supplier as well. So the supplier will be sending you fixed order and fixed amount of things. So exactly that's the only advantage with the 3-bin system, that it adds this one more layer of additional, safety. If you fear a lot much disruptions in your systems, you can really work on with the 3-bin system. One of the same thing in a 3-bin Kanban card system. So the next part is selective inventory control systems or methods, right? Obviously, you have a lot much inventory. If you look into millions and billions of parts, you really need to make sure that you go with a few of them and to really make sure that you organize your overall inventories. So the first one is ABC analysis. That is done through Pareto analysis as well. So exactly, quick thing about the realistic application, ABC analysis, basically, if you look into the warehouses, what happens that warehouses are basically supplying you stuff all around the year, right? So supposedly Amazon has a fulfillment center or a warehouse, right? And they know that in February, people will be looking for stuff that is more relevant to the Valentine's Day, right? In December, they know the people will be looking for stuff more relevant to the Christmas. For April, people will be looking for stuff that is more relevant to the Easter, right? So based on ABC analysis, the high replenishment or the high consumption items are basically placed in the front shelves, right? So if you have a lot much big warehouse that entirely occupies has a space like similar to GIK, so exactly you really can't move all the way from this end to the last end and make to get one of the items from there regularly, right? So this basically, if you have a lot much thousands of order every day, so this really reduces your productivity, right? So you really need to basically stack your shelving. So so supposedly I say it's December and people are more into the Christmas gifts. So the Christmas gifts will be stacked in row one, right? Then will be your medium items that will be in row two, and similarly there will be a row C as well where you have less used items. So exactly to save your cost, right? I could have given much better examples, but obviously really can't take much of your time just to go through this quickly. HML based on unit cost, so high, medium, and low. So there might be a lot much inventory. You might categorize that in based on high unit cost, medium, and low unit prices. Then you have an XYZ that basically takes into account the cost of inventory. So you might store X inventory that has a high value. You might store Y inventory with a less systems and layers, and similarly Z inventory has less value, right? So I can say that X might be something that has values in millions, Y might be something that has values in thousand, and Z might be something that has value in hundreds, right? So I can really basically add layers of security to my inventory as well. Then we have VED, that is more towards your maintenance, repair, operations inventory, vital, essential, desirable. So I say I have a production line. The vital thing is I need to have a conveyor belt. The essential thing is that obviously I have quality checks. I need an LCD, a touch LCD. But obviously, if I don't have a touch LCD, I can go with a mouse operated LCD as well. That's perfectly fine. And desirable is something that, well, you can have that inventory, and if you don't really have that thing, that does not really matter. So if you have oil from brand A or brand B or whatever is really suiting your needs, you can use any of them. Does not really halt your production. The other is fast and slow moving goods, right? So for the fast moving goods, you have a different mechanism of distribution. And for slow moving or non moving goods, you have a different mechanism of distribution. Similarly, scarce difficulties to obtain is more for procurement. So if I say that I really want to procure uranium, that is scarce. If I say I want to procure, someone wants to procure F-16, some country, that is obviously difficult because obviously it all depends on your international relations. And similarly, you can say that, well, if I need to buy 1,000 pens, that is easy to obtain. I can just go and put up tender in the market and the things are easy to obtain. Then you can also categorize your inventory based on Gulf analysis, that is government, ordinary, local, and foreign sources. So simple as that, OGDC has stuff that can be only acquired from the government, right? So if I'm looking for uranium, only the government can allow me. Then ordinary, like my stationery. Then local stuff, something that is being made locally, like pipes, right? Foreign sources, that is something that really needs to be procured from outside, right? So it can be something like boilers, right? Something like generators. Then you have seasonal, off-seasonal. So if I say that Josa mango juice is available throughout the year, Nestle supplies that you throughout the year. You are readily able to get that. So basically, in this sort of inventory, you go for a seasonal and off-seasonal analysis. What happens that within the season, the company really stocks huge piles of inventory that really help the company to basically complete the user's demand over the entire period or the entire year. Right. All right. The other parts of inventory management is periodic and perpetual. Perpetual is more like continuous inventory system. Once the inventory comes into your stock or your store, you simply record that thing and you simply minus that from your records once that's gone out. So this has been mostly replaced by automated systems, this entire periodic and perpetual. So only the obsolete organizations or organizations that have not really improved in terms of their overall supply chains are really working with these methods. The next is periodic inventory systems, where you basically periodically check your inventory rather than checking them regularly. So periodically can be like after 3 months, can be after 1 month, right? Can be after fortnightly as well. You just go and count your inventories and report whatever it is, and report whatever the losses are. So exactly, this means that you are not really working in a just-in-time environment. You have a lot much time for the inventory to come up, and you are not really concerned about the disruptions, right? Now we come on to our inventory models or inventory control systems. The first one is fixed order quantity, right? So fixed order quantity means that you order the same amount of quantity from your supplier every time, right? So quick example can be, our institute, GIK, 100 faculty members, and roughly, let's make an assumption that everyone needs 12 pens a year, right? So you need to buy 1200 pens a year, right? And just make some safety stock as well, like 1400 pens. So every year you'll be basically asking for 1400 pens from your suppliers, right? Exactly, the quantity is not really changing unless a lot more changes are made, right? The next is your EOQ, that is economic order quantity. Then you have a POQ, production order quantity or economic batch quantity, and finally your quantity discount models, right? Let's move on with EOQ, that is economic order quantity. So basically the assumptions with EOQ that the demand is reasonably known, right? It can't be for unknown or disrupted demands, right? Lead time between placement and receipt of order is known, right? So you know that whatever at what time you order and what time you receive the thing, you are really sure about that. Inventory arrives in one batch at one time, right? Quantity discount is not possible. The only viable costs are ordering cost and variable costs. Stockouts can be avoided if ordered at the right time, right? So these are the assumptions. Let's really look how EOQ really works. So we call this as a sawtooth graph. So this is the level of inventory that you require as Q, right? And this is your time, right? So with an EOQ model, we say that all the inventory comes at once. So at this point you ordered, or some other point you ordered, and you have replenished your inventory, right? So at this point you had inventory 0, right? And you ordered inventory and it came up within like the same day or the same time, right? But you still know your overall lead times, right? So it came up and your inventory has been replenished, and over the period of time this has been consumed, right? So this is more of a sort of model. So this is your total order received, this is your rate of usage, and this is your average inventory that you really have on hand, right? So this is just for this model. All right, students, I do have some numerical questions for you with the formulas for EOQ. And EOQ is basically finding a point where your economic order quantity, that means where your holding and your carrying costs are same. And we assume that at that particular point, we will be having less cost associated with inventory, right? So this is the formula for EOQ. Q is your EOQ, D is your demand, S is your setup cost, H is your holding cost, that has already been given. And you find that at this much number of units, our holding and carrying cost will be the same. You can just go through the numericals and you will have a lot of practice. There are solutions as well, so don't worry about them. You can simply have an idea to where your holding and setup cost are same, 50/50, that is 100. That means that at this particular point, by ordering this much amount of units, you really can achieve or have reduced inventory cost. The next thing is to really calculate your reorder point, right? Exactly at what time you really need to reorder your things, right? So this is something that is commonly used. So I say that this is my inventory I've received on day 1, and by day 5 this will be so this is Monday, and this I say this is Friday, right? So it starts all the way from Monday, and on Thursday I say that I am left with few units of inventory, right? So supposedly this was 100 now, and here it is 20. So on Friday, what happens? I order my inventory, right, at 20 units, and I know that I'll be getting, I can consume these 20 units by the end of Friday, right? Because we are assuming that the demand is known, right? So we assume here that 20 units are being consumed for each and every day. So 20 units here, and finally on Friday I'm left with 0 units. But what really happens that within 1 day, if I assume the lead time to be 1 day, I'll say that all right, if I order at this point, I will be getting my inventory by the end of Friday, and on Saturday morning, my inventory, or Friday night, my inventory levels will again reach Q, right? So exactly this is how you calculate your reorder point based on your lead time. This is the formula for your reorder point, that exactly at how much number of units really need to order with your supplier. So just make sure you go through and practice that. The next thing is your EBQ and POQ, economic batch quantity or production order quantity, is something out of the size of production batch, which minimizes the total cost, right? So if you're producing things in batches, you need to order a batch of that much quantity that can really minimize your inventory costs, right? That is your holding and carrying cost. Distribution of the entire production into smaller batches. Calculate the batch size and raw materials. So this is the formula, and this is how a graph for EBQ looks. We assume that the inventory is basically coming up in time. In EOQ, whatever was happening, inventory was coming all at once. In EBQ, we say that over a period of time, we basically gather our inventory, and then over a period of time, the inventory is consumed, right? So the production and usage takes place, maximum inventory. With no production, only usage takes place, right? So this is where your inventory is basically being consumed, right? So this is where it was really being produced over a period of time in batches, right? And this is how it is really being consumed. Again, you manufacture those in batches, and then again it is consumed, right? So this is your EBQ model. Here's the calculation. So C naught is the setup cost, D is the annual demand, CH is the holding cost of 1 unit, and P is the annual production capacity. So most of the things, if you go through this example, this is a very realistic and a common example used for EBQ. Make sure that you go through this. The formula is there. Find an EBQ quantity, the optimum amount of inventory, then you find out the cost, and then you may be able to find out the savings that you have done through EBQ. So make sure that you go through all these numericals of quantity, discount, EBQ, EOQ, and ROQ. All right. These are some recommended readings if you really want to go through. All right, so with this, we come to an end for our lecture of inventory management. I do hope that my students will really be looking into the practice examples and the numericals that have been given to them. I really don't, I won't be getting into that bit because the solutions are there. And infrastructure-based constraint, I really can't make sure that to give you a good practice of the numericals with this infrastructure I do have. Nonetheless, much better to practice at yourselves, because the more you practice, the better you go. So finally, I do hope that with this topic, we have discussed that what is inventory management. We have discussed raw material, work in progress, finished goods, semi-finished goods, or modular assembly types, modular inventory types. Then we also discussed the inventory management systems like VMI, vendor managed inventory, just-in-time, and efficient consumer response. We also discussed things like Kanban card, push-pull production systems, and 2-bin and 3-bin inventory management systems. We also went through selective inventory control methods. Then we had our inventory control methods, that is fixed order quantity, economic order quantity, production order quantity, or economic batch quantity. And finally, we went through quantity discount model as well. That basically tells you that exactly at what quantity you can really achieve the maximum benefits in terms of the cost. So with this, dear students, we come to an end for our lecture. Thanks a lot for listening to me, and hopefully see you soon in the next interactive session for this lecture. Come up with your questions. You can come up with the numerical questions as well, and we'll try to make sure that we go through each and every bit of that. So thank you very much. Good luck.